Okay, there's two inverse property relationships. The first is the following. If you have an exponent in which the power is the log with the same base as your original exponent. So here, if you take the exponential form a to the power of n, where a is your base b and n is a whole logarithm with the same base as your original exponent, you're simply going to have the original amount x, whatever's inside your log up here. And think about how this relates. So if you were to rewrite this in the logarithmic form, you take the log base b of x is equal to what's inside here, log b x. So you wind up having the same thing. So you see that these are equivalents here. Okay, and then we have a second inverse property. To look at, and that's if you begin with a log base b and you have b to the power of x inside your log. Once again, that's also just going to equal x. And again, think about if we were to rewrite this in exponential form, we would take b to the power of x is equal to b to the x. So you can see that those are both equivalents. And really for this second property is going to be the one that we will actually use a little more often because it has a shortcut relationship, and that shortcut is if you're looking at something like this and you wanted to evaluate this, what you can do is we can pull this power out and write it in front of our log. And then log base 2 of 2. Anytime you have a form log b of b, that's always going to equal 1. So this would be another, just a common property involving logs. And so if you move this power out front, you get 3 times log base 2 of 2 has a value of 1, which would evaluate to just your number 3. Okay. So what if I had something like this, 5 to the power of log base 5 of 4? What does that equal based on these properties? Again, it has this pattern right here. You're simply going to equal whatever's inside your log. So you can shortcut, that's just equivalent to 4. Okay, what if you had something that looked like this? Log base 2 of 8 to the x. And I asked you to evaluate it or simplify. And so here we don't have the same base inside as out. Okay, but can 8 be written with a base of 2? Yeah, so you would use that property. 8 is 2 cubed to the x. When you take a power to a power, you multiply the power, so we get log base 2 of 2 to the 3x. And now we can apply this property. We pull our power out front. So it becomes 3x out front. Log base 2 of 2 has a value of 1 using this property. And so you just get your answer of 3x for that expression. Again, because your calculators don't evaluate logs of bases other than 10 and e, you do need to make sure that you can manipulate these by hand.